Okay, sorry about the late start, everyone. We had a lot of devices to set up. You wouldn't believe. I've been carrying around this big blue bag this whole time. Anyway, stop complaining, start presenting. Hello, my name is Arunjit Singh. I usually go by Arun just to make everybody's lives easier, mine included. And we're going to talk about reaching Alexa devices with screens. There's tens of millions of these things out there now. We're going to get into it. Along with me here is Steve Arkonovich. Steve, why don't you introduce yourself?
I'm Steve. I'm the Alexa developer. I'll be talking a little bit about my skill in APL coming up.
All right. So a little bit of time on the agenda. We are going to look at the multimodal vision, do some conceptual stuff, talk about how we got here. I mean, I walked over from Vidara, but that's not what I'm talking about. How we rhetorically got here, the journey, why Alexa presentation language exists, what it does, a hello world sample, because every technology has to have a hello world sample. And then we're going to move into building a more custom layout, or rather inspecting Steve's custom layout, which he has graciously offered to demonstrate, much more real world than my hello world sample. We're also going to talk about adaptive rendering, because there's many Alexa devices with screens, different shapes and sizes. How do you adapt to each of those devices? And finally, I'm going to talk through some unique multimodal features. This is where APL really shines, because it is able to combine voice and visuals to do some very interesting things. We'll see what they are in a moment. So, multimodal vision. Let's take the long view. Let's start in the 70s. The summer of love has just ended. Man's been to the moon. Sorry. Okay. We're using character mode UIs. That's what we're doing in the 70s. We got keyboards, VT100 terminals. That's what's going on. In the 80s, we get drop-down menus, buttons, graphical user interfaces, mice, MacBooks, Macs, all the rage. Next comes the web, which effectively makes graphical user interfaces portable. Now you can download your graphical user interface in a browser. Mobile is mid-2005-ish. iPhone kicks it off. It's a big deal. Touch becomes a first-class citizen of user interface modalities. Get it? Multimodal modalities. Sorry, bad joke. And then, finally, right now we're seeing the emergence of voice. It's another disruption. But the interesting thing is, the old user experience modalities don't go away. You've still got keyboards on your laptops. When you hit an editable text box on your iPhone, a keyboard, iPhone or Android phone, a keyboard still comes up. So they tend to accrete on top of each other. And we're going to see how that matters to Alexa. So here's the idea we had back in 2016-ish. What would happen if we added a screen to one of these Alexa devices? Would it be a distraction? Would it be useful? How would customers use it? So those user experience explorations, those ideas turned into these two devices, the Echo Spot and the Echo Show, both came out in 2017. And we learned a bunch of stuff. Boy, did we learn stuff. We learned that customers love complementary visual content. They love it when, when they ask for the weather, and in addition to telling them what the weather's like today, Alexa gives them information about the next 5 days on the screen. They may choose to engage with it, they may not, but it actually drove up engagement a lot. We learned that people engage more with multimodal devices. We also learned that visuals simplify interactions. When they go looking for a restaurant, like a Chinese restaurant in Vegas, Alexa will read out the top 3 results, put the top 10 on the screen if the device is multimodal, and they can say select the 5th one, and that just works. They can naturally skip a step. They don't have to ask about the next 3 because they saw it on the screen. So it's kind of cool because it simplifies an interaction. It removes a step from the user interaction. Keep that in mind. The third thing they loved a lot was ambient experiences. The home screen giving them the opportunity to engage, showing them news stories, information about Alexa, going into a skill or a first-party experience and seeing hints at the bottom of the screen. It's not intrusive. It just happens. If they choose to engage, they learn something new, and turns out they choose to engage. And finally, rich media experiences. Our kitchen experiences use it to great effect with video. Can't do video on voice-only devices, unfortunately. So media is a great big win for multimodal devices. So we double down on that vision. we expanded multimodal Alexa to a bunch of devices. We put it on TVs, we put it on tablets. Now that all sounds great, but there were problems. When we started this process, we wanted to include skills in it as well. So we did something quick, which was, here's 7 templates you can fill out with information and put on screen. It worked, it let us get the product out faster, but it has a whole bunch of problems. But I'm not going to tell you about the problems. I'm going to let Steve, who ran into those problems, tell you about them.
Hi, everyone. I've been developing skills for several years. Today, I'm going to talk to you about BigSky, which I've recently completely revamped with the Alexa presentation language, and I'm excited about the results. But to make the difference between the pre-APL and the post-APL suitably dramatic, I thought I'd do a bit of a before and after. So what you're looking at here is the weather skill BigSky that I wrote before APL. As Arun said, with the predefined display templates, you had very limited choice. You had like 7 templates you could choose from. And once you chose a template, you were stuck with it. That is, the same display template went to all the devices, no matter what the form factor was. And the templates themselves were quite limited. So I think this template had like 3 elements. You could see it had a background image, a cloudy sky, and a foreground image was a weather icon, and then a text block. And that was it. If I had chosen a different template, perhaps I could have moved the text block around, but it was extremely limited. And it was also extremely limited in terms of its adaptability. Again, the same template was sent to all devices regardless of the form factor. Actually, that's not quite true. There were some very small adaptations, but these were baked in, not up to the developer. So I think with this template, the baked-in adaptation was that the background image was dropped in favor of the foreground image when it was sent to the spot. So for my skill, BigSky, the result was white text on a black background, which was kind of retro, I guess, maybe cool, but not at all what I had in mind. So the limited templates, limited adaptability, I think that really made it difficult to have a compelling experience across all devices. But with APL, a lot of that has changed. So this is what BigSky looks like now with APL implemented. I hope the first thing you notice is that it looks a lot better. And that's because I was able to design custom templates from scratch and sort of realize my own vision for the skill. I could also write custom templates for the different devices, right? So it looks much different on the smaller screen of the spot than on the larger screen of the show. So you get a lot more adaptability. Another thing that's really a compelling feature of APL, and I think this is what's going to draw a lot of people to it, is that you can make the skill look different from all the other Alexa skills out there. Right? I think I heard there's like 50,000 Alexa skills now. And if they're all using the same 7 templates, your skill is going to look a lot like everybody else's skill. So with APL, you really have an opportunity to sort of like brand your skill, make it look unique, and stand out from the other 50,000 skills out there. So Arun's going to come and talk a little bit about the features of APL that make all of this possible.
All right. Thank you, Steve. So before we go any further, Alexa presentation language is what we're going to spend the bulk of our time talking about. What does it do? Why does it exist? Well, it makes skill visuals customizable, which is kind of awesome. I think I hit a button there, which did something strange. It is also adaptable to different devices, as you saw from Steve's screenshot there. It's available on all Alexa multimodal devices, the ones made by Amazon, and soon on device partners' devices with screens as well. That thing up there, that funky looking thing, is a reference kit that we're launching next year. And it's got a Raspberry Pi and a 7-inch screen. APL is going to work on that. And it's got unique multimodal features. I keep talking about this, and I wanted to give you a taste of it. Let's see if the audio works.
Amazon. Open daily travel.
Gouda, sharp cheddar, blue, brie, cheddar, parm.
Yes, those are cheeses. All I did was take one of our APL samples and enable this experience on it. Adding this functionality took about 15 minutes of work. Might take longer if it's your first time with APL. And this experience is actually very similar to what happens on an Echo Show if you ask it to read your shopping list or your to-do list. It's pretty much the same experience. It's now available to any skill that wants to use it. And this sort of experience is super popular with kids. Oh, and there's a puppy on screen. We got Chester, a new puppy, on our team. You don't get this feature. It's not downloadable in the SDK, but I wanted to bring Chester in because he's kind of awesome. He hangs around in our team area and helps us build APL. He's my MVP. That's what he is. All right, let's take a look at BigSky with APL. Steve.
All right, so I'm just going to demo BigSky, making sure I have the device names correct. Amazon, open BigSky. Amazon, open BigSky.
Currently, it's 50 degrees with mostly cloudy skies. Possible light rain starting in 9 minutes, stopping 20 minutes.
Okay, so there's a couple things to notice about this. First, that's the weather for Portland, Oregon. You're fine here. Another thing, again, is the completely custom template. There was nothing like this available before APL. And if I had let Alexa talk a little bit longer, you would have noticed that what come up on screen is another page of display altogether. So this is a really powerful feature of APL, the pager, which basically allows you to create slideshows.
What else can I help you with?
Oops, I got me.
Basically allows you to create slideshows, so you can bring a lot of complementary visual content to the voice-first experience. So that's another way that APL really helps you adapt your skill to a device and across devices. So let's see what BigSky looks like on a spot. Echo, open BigSky.
Currently, it's 50 degrees with mostly cloudy skies. Possible light rain starting in 8 minutes.
Okay, again, a custom template, if you could recall what it looked like on the larger screen of the show. Although it's sort of visually similar, I tried to keep that. It's a completely different display experience, and I think it makes it much more engaging across devices and a much more satisfactory user experience. Another way it's adapted for the spot, the smaller screen of the spot, is that the pager itself is changed. Again, I have so much less screen to work with that instead of trying to get all the information of the pager that I used on the big screen of the show, I spread it out across several, 4 or 5 screens on the spot. And if I had allowed Alexa to keep talking, the slideshow would have worked in conjunction with the voice output. So again, the visual display supporting the voice-first experience. All right, so that's BigSky.
All right, thank you. Switch over real quick, make sure the switch worked. Okay, how many folks here have actually built skills already? Okay, that's a fair number. Okay, so I'm not gonna go too deep into this. This basically is the life cycle of a skill request. It starts with the customer walking up to an Alexa device and saying, Alexa, make sure that thing's muted. Alexa asks BigSky to tell me the weather. And that goes into automatic speech recognition. That's number 2 there, where we basically transcribe what the customer said. Then we turn it over to NLU, natural language understanding, which is where some awesome stuff happens, and we figure out the intention of the customer. Now we take these intents, it's what we call them, and pass them on to your skill, which is expressed by that lambda symbol there, because a lot of skills tend to be AWS lambdas. And once a skill receives this intent, and it can come with some slots. Slots are like arguments. It can respond with a speech output. It can respond with a render document directive, which is how you render APL onto devices. Or it can respond with commands. I'll come back to those. That's number 4 there. That gets delivered to the multimodal components, which send it down to the device, and magic happens. Alexa says something, puts a beautiful view of the BigSky on screen, and sometimes a little depressing when it's raining in Oregon. And that's how it works. What does APL have? You're going to be familiar. It's got basic design language components, images, text, lists, containers, all that is there. Alexa components can be styled. The styles are extendable. If you're familiar with CSS, these styles should feel familiar. Alexa presentation language has resources, named values, basically. These can be strings, booleans, dimensions, whatever you want them to be. One powerful feature of APL is layouts, wherein you can create composite components by putting different primitive components together, containers, text, images, and then reuse them within your skill, but also share them with other skill developers, because our key goal for us is to build a community around APL. As you'll see in Steve's example, when we walk through the custom layouts, he's already built a custom layout that I'm hoping he'll share with the rest of us at some point in time. We're going to build them too at Amazon, but we can't think of everything, so we need this community. There's the when clause, which is a conditional layout. This is how you make your APL documents responsive. If you're familiar with responsive web design, when clause works similarly. You can conditionally present or hide components based on what's going on the device, what your data source looks like, whether the device has a round screen or a rectangular screen, pixel size, DPI, whatever you want. And then commands. Commands is basically your skill sending messages to the Alexa device. Commands is your skill saying, I put this document on screen, now I'd like to change something in this document. I put a pager on screen which has multiple slide items, now I'd like to start a slideshow, for example. That's a command. So, hello world. Every technology has to have a hello world. I will try not to bore you too much, but hello world gives me the opportunity to do a bunch of things. It lets me show you how to create a basic APL document, how to get it into your skill, enable the APL interface, detect APL at runtime, and then render the APL document. We'll look at a much more complicated layout right after this. All right. First demo. Let's see. All right, switched over. OK, so this is my reInvent demo skill, very cleverly named reInvent demo. The first thing you'll notice is the invocation name is demo drama. Remember that? It's super dramatic. The second thing is inside this interfaces tab is the Alexa presentation language interface, which I have turned on. This is you telling Alexa that you will be using APL at some point in this skill. Then, now that we've turned it on, we should go build an APL template. So I'm going to do that again slowly. In here is a new display tab. You pop that open, and you get this new authoring tool. Let me make that a bit bigger. And there's a bunch of sample templates here, which actually map to a lot of all of the current skill templates that are out there. But I've got a hello world template already, so I'm going to start from scratch. Now in here, you'll notice that there's this nice hierarchical view of the template. I'm going to turn that off for a minute because I need to copy in a template. So select this, delete this, switch over to my code editor, and open up demo1 hello world. I've got this document. Julia Child style, I've got it already pre-baked. I'm going to pull it out of the oven. Does anybody know who Julia Child is? No. Copy. And I'm going to take it over here and paste it in. So this is my hello world document. Not a lot going on. Type is APL. Version is 1.0. I've defined a style. The main template is interesting because that's the entry point into your APL document. This is where rendering starts. It takes an argument or a parameter called payload. And then it's got a bunch of items. It's got a frame inside a container. Remember I said there's containers in APL. This is a Flexbox style container. So a lot of Flexboxy things will work in here. And there's a text, which is using that style and bound to a data source. So this funky looking expression here is a data binding expression. So let's bring in the data. So I've got the data source here, which is again another JSON object. I put it in here. OK, now it says hello world. And now the interesting thing here is the payload parameter, which basically maps to this thing here. And if you pay attention to the text, it says, I'll make it bigger, payload.docdata.hello, And so payload, doc data, hello. So if I change it, it changes. And you can see what this template looks like on different devices. You can see what it looks like on a small hub, which closely maps to an Echo Spot, medium hub, the previous generation Echo Show, the current gen Echo Show, large hub, and extra large TV, which is, well, a TV. It could be a Fire TV, for example. Now keep these in mind, because these will come up again. And also, another really cool feature is that if you've got a device associated with your developer account, you can just throw this template onto the device to preview it on the device. So that's really convenient. You don't actually have to write a skill to see APL working. You can just do it from the authoring tool. OK, let's try and run this demo, shall we? So this is my index.js, is the entry point. In the launch handler, I've got show demo1 hello world, because I'm so clever. Let's go to definition. And what we're doing here is we're loading up that document file inside a variable, or a constant rather. We're loading up the data source, and we're putting together a response for the skill. And in the response, we're saying hello world, and we're presenting this document using the render document directive. Let's make this bigger. And here's the document, here's the data source. We also give it a token. We'll come back to why we do this in a little bit. OK. I'm not going to try and deploy it, because it's already deployed. So I'm going to cheat a little bit, because deployments often fail. It's been my experience. Whenever I'm on stage, it tends to happen. So I'm not going to risk that. Instead, we're going to switch over and see that skill working. Amazon, open demo drama.
Hello world.
Okay. On the spot now. Echo, open demo drama.
Hello world.
And I managed to finagle one of these boys. Ooh, if I can hold it up to the screen and unmute it. Remember the reference kit device I talked about? This is that device. Alexa. Alexa. Oh no. Open demo drama. Told you about demos.
Hello world.
Yay! OK, it worked. It's a simple demo. But the idea is you can customize for all of these devices and get it working there. OK, let's switch back. All right, so hello world was pretty straightforward. There's a container. There's a text block inside the container. There's not a lot going on. If you try and ship this skill, or if I try and ship this skill, I'm going to get rejected summarily. Totally acceptable, because nobody wants to ship a hello world skill. What we want to ship is a skill like Steve's. So let's take a look at what building a layout for BigSky looked like. Steve?
OK, so a lot more is going on here visually than in the hello world sample. But really, underneath, it's the same few APL components. So you have a container, which, as Arun said, is sort of a Flexbox style container. And for hello world, all of the visual elements are contained within one main container. Containers contain other APL components. For example, there's a text object up there that's, in this case, just showing the time. There's some images, for example, the background image. And importantly, APL containers can hold other APL containers. APL is a very hierarchical structure. And so inside the container on the left, there'll be more APL components. So for example, more images, more text, and a new component hasn't been mentioned yet, which is called a frame. The cool thing about frames is they can take background colors, including transparencies. And so what you're looking at on the left-hand side there is a container, which is the child of another container, which itself has a frame as a child, which is then taking a transparent background color. On the right-hand side of the screen, you see these circular visual elements. They look much different. I call them info circles. But under the hood, they're built up out of the same basic APL components: frames, containers, text objects. But they really demonstrate a powerful feature of APL, the extensibility, right? Because I was able to build these info circles from scratch myself And then once they were built and defined, I was able to deploy them in the APL document the same way you would deploy a basic APL component. So this might be easier to see if we look at the actual APL document. So I'm going to switch. Right. I'll get rid of this thing. There we go. So this is the APL document for BigSky. I'm going to paste it into the authoring tool. Doesn't look so great yet. It needs a little bit of data. So I'm going to take the data source, put it in here. So this will bind to the APL document. And this is a APL document that's meant for a larger hub. OK, and so there, I'll make this a little bit bigger. There's the visual display of a BigSky screen. So let's look at the APL document itself. I just want to go through here and show you how the visual elements are described in the APL itself. So I said at the beginning that for BigSky, all of the APL components are contained within one central container. So you can see that here, just below the main template, sort of the entry point for the APL. You can see that, can you see this? Maybe you can. You can see that there is a description main container. And then for APL, the way you deploy or the way you use an APL component is you simply declare the type. So here I declared the type, and together with some of the parameters that a container type will take, including an item parameter, which is an array which allows you to declare sort of child APL components within that container. So for example, there's an image. I said that, right, the background image, the text, that happened to be the time. And if you remember off to the side of, on the left-hand side of the screen, there was another APL container, which is here declared, right, another type container, and within that, the frame right here, and which takes a semi-transparent background color, right? And so that's how, this is how it looks in the APL document itself. The circular visual features, the info circles that you saw, if you scroll down, you'll see that they are used in exactly the same way as the basic APL components, right? Again, you simply declare the type here, an info circle, right? Even though the info circle isn't a native feature of APL, you had to create it yourself. Once it's defined, you use it just the way you would a native APL component. You just define the type, declare the type, and then you can adjust whatever parameters that type of APL component takes. What I want to do is just scroll up and show you how you define a custom template, which you can then use throughout the document. There's a section of an APL document called the layout section. And in the layouts is where you define your custom APL components. And so here in this layout section, I start to define an info circle. I say, look, an info circle has these parameters. And then I pass those parameters through some data binding to the component parts of the info circle. I'm not going to get too far into this. You can see that the info circle itself is pretty complicated. It just keeps going down. I think there's like 13 or 14 basic APL components that it's built up out of. But again, once those are defined in the layout section, you can then use that custom layout throughout the APL document just the way that you would use a native APL component, an image, a text, a block, etc. You just declare it. Yeah, so I think I'm going to hand it back to Arun, who's going to talk about some more features of APL.
Okie doke. Thank you. Switch back. Make sure I press the right button. There's actually like, what, 20 blinking buttons back here, you guys. So I have to be careful what button I touch. OK. Promised a really complicated template. I think Steve delivered in spades. It's great, though. Like, how long did it take you to do the first version of that template?
15 minutes. No, 2 weeks. 2 weeks.
15 minutes would have been, okay.
Were you just noodling on all those little things for hours? Like, what's the actual process of like getting this to look good?
Oh, we're gonna save the questions for later.
Oh,
I'm sorry, I don't want to shut you down, but because nobody can hear you because you're not mic'd up. Okay, so adaptive rendering, that's the next thing I want to talk about. I hinted at this. There's a lot of Alexa devices with screens out there. And obviously, there's Alexa devices without screens, the speakers, which are out there as well. So how do you adapt your experience to all of these different devices? Because Steve's done that, so clearly it's possible. We should learn how. Alexa is going to be on a lot more devices. We've got a lot of device partners attending reInvent, working on these devices, coming out. Sonos has one. There's a lot of speaker ones, but you're going to see ones with screens come out soon as well. So there's 3 strategies to adapting your experience to an Alexa device, and you can use one or more of them. Number 1 is we deliver information about the device's viewport to your skill service or skill lambda as part of the skill request when we invoke, well, your skill. And this viewport information includes the DPI age of the device, pixel width, pixel height, the shape of the device. Is it round? Is it rectangular? What kind of inputs it supports? All sorts of interesting things. And also, our Node.js, Python, and Java SDKs have helper libraries and helper methods that let you take this information and categorize it into those same categories you saw in the authoring tools: small round hub, medium-sized hub, large hub, so on and so forth. So it makes it easy to do that sort of categorization in the skill lambda. And Steve just that. And the other approach you can use is when clauses, which are inside the APL document itself, making them responsive. Steve's going to talk about both of them.
Yeah. Okay. So I'm just going to go over some of the points that Arun just made, looking at some actual code. Okay. So again, there's a couple ways to adapt the APL in your skill. The first way is adapting it within the skill lambda, that is adapting the APL within the skill code itself. So I'm going to take some more. So maybe the quickest way to understand how to do this is to take a look at the skill request. So if you can see here, everyone or a lot of people have already built Alexa skills. This should seem familiar. This is an Alexa skill request. The part that might not be familiar is this part here, the viewport portion of the request. As Arun said, now when you get a skill request with APL, you get a lot of information about the physical characteristics of the device that the customer is invoking the skill on. So for example, the pixel height, the pixel width, roughly the size of the screen, the DPI, the modalities that the user can interact with on the device, like can you touch it, can you interact with it on a keyboard, on a remote control, etc. Okay, so you get all this information now in the skill request itself. And then you can use that information in your skill code, in the skill lambda. So let me just find. So here is sort of a mock-up of a skill. Here's a handler that you might use. And so in the handler, right, you detect APL support. And depending on the device characteristics, you could send out a different APL document to each device. Now, as Arun said, if you use the SDK, there's some convenience methods for you, something called a viewport profile. The viewport profile simply corresponds to a collection of viewport characteristics that we just saw, like screen height, pixel depth, etc. So you can tell, for example, that if the user is using a device that corresponds to a viewport profile of a small round hub, that means roughly that they're using a device with the device characteristics of a spot, right? You would send this APL document. On the other hand, if the device corresponded to a viewport profile of a medium hub landscape, which is roughly a first-generation Echo Show, you would send a different APL document, right? So the idea is the skill request gives you all this information about the device they're using, and then you can send different APL documents to those devices depending on the characteristics. Another convenient thing about using the SDK is that these viewport profiles correspond to the simulator in the authoring tool, right? So you can see in the authoring tool, you have a large hub, or the medium hub, or a small hub, which again roughly corresponds to an Echo Spot. That APL document looks terrible on Echo Spot, so it's a really good argument for adapting what APL document you send depending on the device characteristics. The other way to adapt the APL document is to adapt it not in the skill code, but in the APL document itself, and this is done with when clauses, as Arun said. So a when clause is just basically a condition, and if that condition is met, you can tell the document to render or not to render certain parts of the APL or modify certain parts of the APL. So let's take a look at how this works. So I'm going to grab another APL document from BigSky, paste it into the authoring tool. I believe this is supposed to be displayed on a large hub. Again, we need to grab some data to bind to the document. Paste it in here. And OK, there we go. OK, so there's a BigSky APL display. What I want you to focus on are the two circles in the center, which show the percentage of the probability of rain and the cloud cover percentage. So those are displayed. But if it was a clear day and there was no chance of rain and there wasn't a cloud in the sky, I might not actually want to present that information to the user and make the screen a little bit more cluttered than it needed to be. So if we look at the APL document, this should start looking a little familiar. Once again, we get to these info circles, which are used simply by declaring the type info circle. I don't know if you can see this here. This particular info circle I call a precipitation circle, right? It just shows if it's going, the percentage, the probability that's going to rain. What's different about this APL component is that it begins with a when clause, right? And the when clause just says, look, if the probability of precipitation is equal to or greater than 1%, then show this APL component, right? If there's no chance of rain, then it won't show this APL component. That's what a when clause does. So if we go to the data itself, right, we can see here that it's, well, never mind. We go to the data itself, we can find the precipitation probability down here. Yeah, there it is. So it's at 30%. Now if we changed it so that there's actually no chance of rain at all, those circles will disappear, and the APL document itself is modified. So it's not just that the circles disappear, but the actual distribution of the other information on the screen itself adapts. Right? So this is a super powerful feature. So here I'm using the when clause to modify the APL depending on the data that's brought down from an external API at runtime. Right? So that's a really powerful way to make sure that you're displaying just what you want to display for a really good consumer experience. OK, so those are two ways that you can adapt the APL document. You could do it in the skill code itself, or you could do it in the APL document. There's another way to use adaptive rendering, which Arun is going to talk about, which is adapting for touch.
Thank you. Wrong button. Had to happen once, right? Hitting the wrong button, it's happened. I think we're good now. OK, so we've talked about adapting in the skill lambda. We've talked about adapting in the when document, in the APL document using the when clause. The third thing I want to talk about is adapting for inputs. Now, Alexa devices tend to have inputs other than voice, especially ones with screens. Echo Show and Echo Spot and hub-style devices, including tablets, have touch. whereas Fire TV has a D-pad based remote control. Other TVs have similar inputs. And so we've got the touch wrapper component, which does exactly what it sounds like it does. It wraps other components and makes them touchable. Not just touchable by screen, but also touchable by remote controls. All you do is wrap your container, image, text, you choose what it is, in a touch wrapper, set it up to send an event on press. You can send arguments as well. As you can see, the arguments can be data bound, so you can actually take the state of whatever's going on the device and send it up. And then on the other side, what happens is that it gets delivered as a user event type skill request. So if we go back to the diagram that I showed off at the start, the skill request life cycle, two things happen differently. One, the customer touches a touch wrapper, either by using the remote control or by touching the screen, depending upon the device. And your skill gets a user event skill request instead of a voice intent skill request. Everything else looks the same. Your skill can still respond with voice or an APL document and or an APL document or whatever it needs, but those two steps change because the input's coming in from a different modality. Okay, I've been promising unique multimodal features. We're going to look at a demo of one because that's how much time we have, but we've got samples up there for other multimodal features as well, including the speak item feature that the slideshow feature that Steve uses in BigSky. But before we get into these unique multimodal features, we should learn about the primitive that powers these features. So APL commands. Commands are very simple. It's basically your skills sending an Alexa device a message saying, hey, remember that document I just sent out? I want to change something in it. I want to change its audio or visual presentation in some way. And the way APL commands get delivered is by way of the execute commands directive. So render document is how you render an APL document. Execute commands is how you modify an APL document in some way, shape, or form. So the one I want to get deeper into is called speak item. Actually, it's a family of commands, speak item and speak list, that create two similar but slightly different interactions. What speak item does is it asks Alexa to speak a block of text that's on screen. This is very similar to the Alexa tell me a joke style experience that you might have encountered on Echo Show devices, where Alexa will read a line of text while highlighting it. Super popular with kids. Some point, I know that some kid's going to learn how to speak a language using this stuff, and it's going to blow our minds, but we'll see about that. Speak list is similar. It's read my shopping list, read my to-do list, just read a list. Similar looking thing. It highlights the list items as it reads them. So let's look at a code demo. Let's look at it actually working. Okay, switched over. So I am going to bring up another APL document. You'll see plenty of these today. So this is actually the same APL document that we started out with, very similar to the Hello World document, the same single style, the same single text. But there's a couple of interesting things going on with the text here. Number one is the text has an identifier. It's called joke text. Identifiers are optional, but you need them in order to refer to them when you send down the command to execute on the text box. Otherwise, how are you going to identify which text box to execute the command on? It's still got the text, but it's also got this other property called speech. So that's what I want to dig into a little bit. Now, if we go look at the data source, because the property is bound to something in the data source, a property called primary text speech, keep that in mind. And if we go look at the data source associated with this guy, primary text looks like a text. We'll see the joke. Don't read the joke yet. It's not actually very funny because I came up with it, but it's a joke. This is why I'm not the content PM on the jokes team. Anyway, and then it's got this thing called a transformer. And what it is doing is it's taking that input, and it's called SSML to speech, but you can just feed it plain text if you want to. It doesn't have to be SSML. and it's taking primary text and it's converting it into this property called a primary text speech. This transformation will happen as the data source is making its way through Alexa service down to the device. So by the time this document actually gets to the device, this property will exist and speech will be bound to it. That is my promise to you. Let's see if it actually works. Okay, so inside of index.js, see if I can find it. There we go. I'll zoom in a little bit. Inside of index.js, I've got a handler for the joke intent, which is so cleverly named. Can you figure out what it does? It tells a joke. And the joke intent handler is right here. And what it does is it sends down that render document, and then following that, it sends another directive called execute commands. Now, in this case, I am putting the joke on screen and then asking Alexa to read it. The way I'm doing that is by putting a speak item command inside the execute commands directive and pointing it at the joke text. The other thing I'm doing is I'm using that same token in both the render document and execute commands directive. So this is how we identify which APL document to run the commands on. And it also says highlight mode line, which is basically telling Alexa to highlight the joke line by line. So let me refresh my memory on what an utterance for that intent was. So there's joke intent, and let's use the simple one. Let's just say joke. Let's switch over and see if we can get Alexa to tell us a joke. Amazon, ask demo drama to joke.
Knock, knock. Who's there? Lexa. Lexa who? Alexa.
My nephew, who is 6, finds this very funny. Just have you know. Say it on an echo, on a spot. Echo, ask demo drama to joke.
Knock, knock. Who's there? Lexa. Lexa who? Alexa.
Okay, you can imagine the possibilities with this sort of thing and what you can do. I foresee a storytelling skill that my nephew is absolutely going to love, coming from one of you any day now. So I'm waiting, just so you know. Okay, we don't need the video because the demo actually worked. That's great. Okay, the other thing you can do with APL commands is present slideshows. This is super useful for travel skills, for example. Kayak built a skill using APL. They're using slideshows. They work great. You want to show pictures of a location. You want to show memories from a specific date. Any number of scenarios are possible. And there's a couple of commands that can power slideshows. One is the auto page command, which is very much like saying, hey, here's a bunch of items inside a pager component. Flip the pages on the pager every 4 seconds or every 1 second, whatever you choose to do. The other command is set page. Take me to page number 4. And you can do that with the set page command. Okay, talks like this. I always think about what I would say to my manager at our next one-on-one, because they've spent a bunch of money sending me here. Now, if you're working on your own, more power to you. Like Steve over here, you're your own boss. But what do you do after you get home after attending this talk? What are the actions you can take? And what are the things you can think about? Well, the first thing I want to call out is that there are tens of millions of Alexa multimodal devices out there already, and more are coming from partners. That's what that reference kit is all about. I also want to call out that visuals deepen engagement. Not only do customers engage more with multimodal devices, they engage for longer periods of time. Also, APL is the way to build visuals on multimodal devices. And APL can adapt to different kinds of devices. So that's really powerful. And finally, it can be used to build this sort of multimodal experience that we just saw. So right now we have about 10 commands, but we'll keep adding them. We'll continue working them. But we need your help as well. We want you to build composite components like Steve's info circle and put them out there for other skill developers to share. And we make this possible and easier, I think, with the concept of imports. So look them up in the documentation. Imports is basically how you import components from another developer your own package into your Alexa document. Here's a bunch of links. The technical documentation is up there if you want to take a picture, but I would search for APL overview or Alexa APL overview. It's usually the first hit. The design guide is well worth a read. We spent a lot of time figuring out what the best visuals are to go with voice first experiences. There's a lot of really, really good recommendations in there, and they'll also help you pass certification faster. The authoring tool, like I said, is usable even if you don't have APL in your skill. You can try out stuff, you can push it to your device, you can see what it'll look like before you even start building a skill. We've also got samples on GitHub. This repo on GitHub is Alexa-labs, keep that in mind. The way our sample pipeline works is that samples start out in the lab repo and then graduate to the Alexa repo. So Alexa repo will have these samples soon, but you can go hit Alexa-labs to see a lot of these samples. We are in public beta now, which means that you can use any of this functionality right now, build skills, submit them for certification, we'll certify them and take them live. So it's all usable right now. There's no repeats. This was the repeat. That slide's in there. There's some related breakouts. All of these have already happened or are happening right now. But the reason I have these on here is so that you can go watch videos of these later at home. We also have a challenge going on. We have the Alexa Skill Multimodal Challenge. There's $150,000 in prizes. Go build yourself some multimodal skills. There's the potential to build a bunch of money. But don't build it for the money. Build it for the engagement and build it to make your customers happier. Thank you very much. This is my contact information is wrong. You know what? I'm going to fix it right now because I think we have a minute. Yeah, how many talks has a speaker gone up and modified the presentation on stage? Not that many. Now, if I could just type, that would be great. All right, fixed it. It's just like fixing a bug. All right, that's my Twitter handle. Tweet at me. If you're more into email, tweet at me and I will give you my email address. And definitely fill out our survey and rate us accordingly. Let us know what we did right, what we did wrong, so we can fix it next year. I'm going to leave the contact information on screen. Thank you very much. We've got some swag down here if you want it. Thank you.